Next we have an assignment operators. So let us use the same variables, or we can change the variables, like x is equal to, say for example 3, and then y is equal to 20, or y is equal to 7. Now we have in assignment operators, the first one is variable assignment, means value assignment, the simple equal symbol. Okay, that is nothing but assignment operator, just variable assignment operator. So inside the print statement, if I use z is equal to x plus y, let us see what happens. So it results error, so we can't use an expression inside the print statement directly. So let us keep z is equal to x plus y, and then print the result z. So let us see what if we can do the expression within the parenthesis, z is equal to x plus y. Then also it results error, invalid syntax, so we can't use that expression. So anyway, let us continue with the add and. Next we have an add and, so it is equal to or equivalent to suppose we know the value of z, that is 10. If z plus is equal to x, then it can be written as like this: z is equal to z plus x. So this term is equivalent to expressing the term like this: z plus is equal to x is nothing but z is equal to z plus x. How to read this is, it adds the right operand to the left operand. Right operand is nothing but x to the left operand. So here is the operation. It adds right operand x to the left operand z. So this is the operation. It adds right operand to the left operand and assigns the result to left operand. So the left operand is nothing but z. So you can see the left operand is nothing but z. So the result will be added to the left operator. So this is nothing but add and assignment operator. So let us see, z plus is equal to x. So z here is nothing but 10, our previous value, and x is nothing but 3. So the result will be 13. Okay, next we have minus and then. So it is like z minus is equal to x, and it is equal to z is equal to z minus x, means it subtracts the right operand from the left operand. So this is the right operand from the left operand. So this is the operation, and assigns the results to the left operand. So left operand is nothing but obviously g only. So g minus is equal to x. So it will perform g minus x and assigns the result back to the left operand, that is g. So here g is nothing but 10, the previous value, and then x is nothing but 3. So 10 minus 3 is nothing but 7. So our g value will be 10 only. Why? Why it is 10? Sorry, I am sorry. Our previous value of g is 13. So that's why it is taking this value. So I am very sorry. That's why it is taking this value 13, and then it is subtracting the value 3 from this 13. So 13 minus 3 is nothing but 10. So we should be very careful about the previous value. Okay, so in order to check the previous value of any variable, we should use underscore and then that variable. So here not defined. Okay, so just underscore, yes, 10. I'm sorry, yes, we should use only underscore. So here you can see 10 is the previous value of z, means the last value used in our interpreter. This is 10. So let us move on to the dividend. So here I am also doing some work just to illustrate that whenever you got stuck, you can go for help. Okay, so I will show how to get the help in this video after completing this session. So dividend is equal to, means g divide is equal to x is equivalent to g is equal to g divided by x. So let us do that work. G is equal to x. So now remember that the recent value is nothing but 10, that is g, and x is nothing but 3. It has not changed. Okay, so 10 by 3, and the result will be assigned back to the g. Let us see what is the result. 3.33. Yes, 10 divided by 3 is nothing but 3.333. Next we have modulus and. Means g modulus and x. So this is equivalent to g is equal to g modulus x. So let us use this. G modulus is equal to x. Okay. Let us check the answer. This is 0.333 means it takes modulus using two operands and assigns the result left operand. Because our previous value of g is 3.333. Okay, the previous value of g is nothing but 3.333 and x is nothing but 3. So 3.333 divided by 3, obviously the remainder is 0.3333. Okay, so it results remainder. Whenever you got the division with the symbol modulus, it always results remainder. Next we have the floor division. Is equal to means g is equal to x. So this is equivalent to g is equal to g floor division of x. G is equal to floor division is equal to x. So here the floor division for g is nothing but 0.333. let us check what happens. What is the result? 0.00. So in order to show how the floor division works, let us assign the value of g once again to 13 and let us do the operation once again. Yes, now you can see x is nothing but 3 and g value is nothing but 13. So floor division results quotient value. So 3 4s 12. So remainder is 1. Let us check whether we got the remainder as 1 or not. Again by using z is equal to 13 and g percentage is equal to x. Yes, we got 1 as the remainder. So finally we have an exponentiate, that is star star is equal to means g star star is equal to x. So this is equivalent to g is equal to g star star x. Nothing but g is equal to g to the power of x. So let us assign the value once again to 13 And now let us perform G star star is equal to x, means G is equal to G to the power of x. Here G is nothing but 13 to the power of 3. Okay, because x is 3. Let us write the comment here. G is equal to 13 and x is equal to 3. Let us execute G. So we got 2197. If you do this with the calculation, we will get the same. Let us see using the calculator. Next we have bitwise operators. So bitwise operators are used to perform bitwise operation between the two values. So here the values are represented in the form of bits. That means a series of zeros and ones, binary values. And in this bitwise operation, the bitwise operators works on bits and performs bit by bit operation. Suppose if we have the value of x is equal to 60 and then the value of y is equal to, say for example, 13. Now in the binary format, these numbers can be represented as x is equal to x is equal to 00111100. Let us separate the bits exactly. Next, y can be represented as 000 and then 1101. Now let us perform the bitwise operators. Bitwise AND, bitwise OR, bitwise XOR, bitwise binary ones complement, bitwise left shift, and then binary right shift. So let us start with the binary AND operator, means binary bitwise AND operator. So here bitwise AND operator copies a bit to the result if it exists in both operands. So for example, here we have x and y. So look at here, the bitwise binary AND operator copies a bit to the result if it exists in both operands. Here the operand is nothing but x and y. So here you can see the element wise element operation. X, observe the last digit is 0, and in y the last digit is 1. So there is no common items, means common elements. There is a mismatch. So that's the definition. Copies the bit to the result. Okay, copies the bit to the result if it exists in both the operands. So in x, the first digit is 0 from the right side, right to left, and in y the first digit is 1. So it will not copy. Again, second one is 0 0, so it will copy the value 0, and in third case 1 1 copies, 1 1 copies, and in fourth case 1 0, it won't copy, the result will be 0. 1 0, it won't copy, the result will be 0, means false. And in the next case, that is 0 0, both are 0, so result will be 0. Both are 0, the result will be 0. So let us do this operation. Binary AND operation. That is x and y. So this is nothing but the binary operation, x and y. Let us do this, x and y. So here we got the result in the form of an integer, okay, 12. The actual result will be like this, 0 0 1 1 0 0. So here look at the method of calculating this 12. 0 means first one, binary equivalent. 2 to the power of 0 is nothing but 0. Sorry, 0 into 2 to the power of 0 is nothing but 0, plus from right to left, okay, 0 into 2 to the power of 1. So 0 into 2 to the power of 1 means again 0. So 1 into 2 to the power of 2, and then plus 1 into 2 to the power of 3. So 0 into 2 to the power of 0, 0 into 2 to the power of 1, 1 into 2 to the power of 2, plus 1 into 2 to the power of 3. So 0 1 2 3. If we do this calculation, then 2 to the power of 3 is nothing but 8, plus 2 to the power of 2 is nothing but 4. So 8 plus 4 is nothing but 12. So our answer is correct. So let us go ahead. With the binary or. So this can be written as x or the symbol like this. So let us do the operation x so it results 61. You can do the calculation similarly what I did for x and y. So here it copies a bit if it exists in either operand. So either operand means 0 1 means 1, because the true value exists in either of the operand. The true value 1 exists in y, so it results 1 in this first case. Next, 0 0, x is also 0, y is also 0, so result will be 0. So in the third case, 1 1, result will be 1 1 1, result will be 1 1 0, result will be 1 1 0, result will be 1, and the last two remaining values will be 0. And you can calculate the value after doing this calculation. Okay. Next we have binary XOR. And the symbol is XOR Y. Let us do that. X XOR Y. The result is 49. So how it operates means it copies the bit if it is set in one operand but not both. So here if you observe, in x and y, 1 1 1 1, they exist in both the operands. So these will be skipped and these will be made as 0, and the remaining 1 appears in x, if you look at here, and 0 appears here. The explanation is very simple. It copies the bit if it is set in one operand but not both. Means the value should exist, the true value should exist in either one of the operand. Here the true value will be treated as 1 and the false value will be treated as 0. Okay. So in the first case, from right to left, in x we have 0 and in y we have 1. So it becomes 1, result becomes true. And in the second case, 0 0, the result will become 0. And in the third case, 1 1, again the result will be 0. Again the result will be 0. Here the result becomes 1, result becomes 1. And here 0 0 0 0. So you can do this calculation manually, and also here you can see the answer here what we have did for your reference. Next we have binary ones complement. So it can be written as either x binary complement of x or binary complement of y. Let us do the binary complement of x. It is minus 61. Means 1 1 0 0 0 1 1 in 2's complement form is due to a signed binary number. Okay, this is due to an signed binary number. Because of the complement. Okay, binary ones complement. Next we have binary left shift and binary right shift. So binary left shift will be like this. X will be left shifted towards the left with 2 digits, for example 2. Let us do this with the x left shift the x value is moved left by the number of digits specified by the right operand. Here the left operand value is moved left. Okay, this left arrow indicates it is moving towards the left by the number of bits specified by the right operand. So here the right operand, for the sake of understanding, I am using 2. You can use any number. So I am moving this x value, means this is 0 0 1 1 1 1 0 0 towards left by 2 bits. Okay, so the number of bits is 2, means I am moving this 0 0 1 1 1 1 0 0 towards left by 2 bits. Let us see what happens. So it results in the decimal value 240. So we need to convert this into an equivalent binary form. If we convert this into an equivalent binary form, we will get 111000. Next we have binary right shift. So this can be written as x right shift by 2 bits. So we need to read this as the left hand operand's value is moved towards right by the number of bits specified by the right operand. Here the right operand value is 2 and the left operand value is 0 0 1 1 1 1 0 0. Let us do this. The result will be in the form of decimal value 15 decimal value. Binary equivalent is 0 0 0 1 1 1. Okay. So this is all about the Python bitwise operators. So here I have shown for binary operators, means in the form of 0 0 zeros and ones. Still, if you get any doubt, then you please rewatch this portion of the video And still, if you get any doubts, just ask me in the question and answer section, or you can comment me to know the answer for this. Okay, I will try to make a separate video for this to explain in detail.